So students, first question on relation and function. For 5 marks in model question paper he has asked, check injectivity and surjectivity of function. So injectivity means 1 1, surjectivity means onto of function from real to real. So from real to real, and as defined as f of x is equal to 3 minus 4x. Is it bijective function? If the function is both 1 1 and onto, we call it as a bijective function. So first, if I take given function f of x, he has given it as 3 minus 4x. So first we will see 1 1. First we will see 1 1. That is injectivity. So to check 1 1, first we take let f of x1 is equal to f of x2. We take f of x1 is equal to f of x2. Then we will solve this. If I get x1 is equal to x2, then we say that function is 1 1. If I get x1 is equal to plus or minus x2, or if I get more than 1 values, then it is not 1 1. So f of x1 is equal to f of x2. So I will substitute x1 in place of x. So I will have 3 minus 4x1. If I substitute x2, 3 minus 4x2. Now simplify. What I do generally, I will take all the terms in RHS to the LHS, so that in further problems you don't get confused. So if I take these all terms to the LHS, 3 gets cancelled. I will have minus 4x1 plus 4x2 is equal to 0. So if I take to the LHS, 3 gets cancelled, minus 4x2 becomes plus 4x2. If I take minus 4 common, I will have x1 minus x2 equal to 0. So this minus 4 you take it to the RHS, you will have x1 minus x2 equal to 0. So or you can say x1 is equal to x2. So if you get x1 is equal to x2, we say that function is 1 1. So you can say therefore f of x is 1 1. Clear students? So take f of x1 is equal to f of x2. Substitute x1 in LHS, x2 in RHS. Take all terms of RHS to the LHS. Simplify. If you get x1 equal to x2, function is 1 1, else it's not 1 1. In second step, onto. So onto. So for all values of b belongs to R, it is a real number. I should get A also belongs to R. A is also belongs to R. So B will be in this second set, that is real number. A will be in the first set, this real number. Here I will take let f of A is equal to B. F of A is equal to B. Now you simplify this and find the value of A. If A is a real number, then the function is onto. If it is not a real number, then it's not onto. So for all values of B belongs to real number. So f of A. So f of x is 3 minus 4x. So f of A will be 3 minus 4a. So 3 minus 4a is equal to B. Now solve this and find value of A. So minus 4a is equal to b minus 3. I have taken 3 to the RHS. Change the sign. 4a is equal to 3 minus b. Therefore a is equal to 3 minus b by 4. Now if you observe here, you have got this as a rational number in the form of p by q. So you have got it in the form of p by q. So p by q will not be a rational number when q is equal to 0. So q should not be equal to 0, then it will be a rational number. If it is a rational number, every rational number belongs to real number. So every rational number belongs to real number. So here, denominator there is 4. In denominator you are not having 0 or it cannot become 0. So you can say this belongs to R, real number. So ಇಲ್ಲಿ denominator ಒಳಗೆ 0 ಬಂತಂದ್ರೆ ಅದು ರಿಯಲ್ ನಂಬರ್ ಆಗುದಿಲ್ಲ. ಸೊ ಇಲ್ಲಿ ಡಿನಾಮಿನೇಟರ್ ಒಳಗೆ 0 ಬರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಏನದ ರೀ 4 ಅದ. ಸೊ ಆಸ್ ದೇರ್ ಇಸ್ 4 ದಿಸ್ ಕೆನಾಟ್ ಬಿಕಮ್ 0. ಸಪೋಸ್ ಇದು 0 ಆಯ್ತಂದ್ರೆ ರಿಯಲ್ ಆಗುದಿಲ್ಲ, ಬಿಕಾಸ್ p/q ಒಳಗೆ q ಶುಡ್ ನಾಟ್ ಬಿ ಈಕ್ವಲ್ ಟು 0. ಸೊ ಆಸ್ ದಿಸ್ ಇಸ್ ನಾಟ್ 0, ಸೊ a is a real number. So for all values of b belongs to R, a belongs to R, ಅಂದ್ರೆ ಇದು ರಿಯಲ್ ಆಯ್ತು. Therefore you can say function is onto, f of x is onto. So if a function is both 1 1 and onto, then we say that it is a bijective function. So finally you can write as f of x is both 1 1 and onto, both 1 1 and onto, it is bijective. It is bijective. Clear, students? So in model question paper he has asked this for 5 marks. Then we will go for the second one. So second one, again same, he has asked to check whether function is 1 1 onto and if it is bijective. This he has asked in model question paper 2. So again if I take solution, first given function is f of x is equal to x square, and here function is from n to n, means both sets are natural numbers. N is a natural number. So first if I take 1 1, if I take 1 1, so let f of x1 is equal to f of x2. F of x1 is equal to f of x2. Now again substitute x1 and x2 in this term. So if I substitute x1, I will have x1 square is equal to x2 square. So in last problem I told, take all terms from RHS to LHS. So I will have x1 square minus x2 square is equal to 0. Now simplify this. So here I will apply a square minus b square. So this will be x1 plus x2 into x1 minus x2 is equal to 0. Now here, if you observe these two, either x1 plus x2 is equal to 0 or x1 minus x2 is equal to 0. Therefore, x1 plus x2 equal to 0 or x1 minus x2 is equal to 0. Here, he has given from natural to natural numbers. So natural numbers means you start from 1, 2, 3, 4, so on, all are positive. So if both are positive, you will never get this as 0. So x1 plus x2 or x1 minus x2 is equal to 0. Here you will never get x1 plus x2 is equal to 0. So this is not equal to 0 because x1 comma x2 belongs to n, natural number. So as all natural numbers are positive, this is not equal to 0, means compulsory which is 0, x1 minus x2 equal to 0. So x1 plus x2 is not equal to 0, therefore x1 minus x2 equal to 0. So now take x2 on that side, therefore x1 is equal to x2. You can say f of x is 1 1. F of x is 1 1. Clear, students? So here I have taken it to LHS. Simplify a plus b, a minus b. A plus b will not be equal to 0 because both are positive. So compulsory which is 0, x1 minus x2. So if you simplify, you will have x1 equal to x2. Therefore f of x is 1 1. Now we will see second one, onto. So if I take onto, second onto. So for onto, for all values of b, For all values of b belongs to n, I should get a belongs to n. So b will be in the second set natural number, a should be also a natural number. Now if I again simplify, so let f of a is equal to b, I will take, simplify and find the value of a. So f of a, if I substitute, I will have a square is equal to b, therefore a is equal to root b, a is equal to root b. Now here if you see b is any natural number, if you are having root, then a will not be a natural number. For example, understanding, if I take example, suppose I will take b is equal to 2. 2 is a natural number, therefore a is equal to root b, therefore a is equal to root 2. Root 2 is not a natural number, so this does not belongs to n, therefore it is not on 2. Clear students? ಸೊ ಈಗ ಇಲ್ಲಿ ಬಿ ನೀವು ಯಾವುದು ನ್ಯಾಚುರಲ್ ನಂಬರ್ ತೊಗೊಂಡ್ರಂದ್ರೆ ಪ್ಲಸ್ ಇದ್ದದ್ದು ಯಾವುದು ತೋರಿ 1 2 3 4 ಹಿಂಗೆ. ಸೊ ಎಲ್ಲದಕ್ಕೂ ಇದು ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಅಂತ ಬರೋದಿಲ್ಲ. ಇದು 4 ಇದ್ರೆ 2 ಆಗ್ತದೆ, 3 ಇತ್ತಂದ್ರೆ 2 ಇತ್ತಂದ್ರೆ ಹಿಂಗೆ ಇರ್ಯಾಷನಲ್ ನಂಬರ್ ಬರ್ತದೆ. ಸೊ ದಿಸ್ ಡಸ್ ನಾಟ್ ಬಿಲಾಂಗ್ಸ್ ಟು ಎನ್, ದಿಸ್ ಡಸ್ ನಾಟ್ ಬಿಲಾಂಗ್ಸ್ ಟು ಎನ್. ದೇರ್ಫೋರ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈಸ್ ನಾಟ್ ಆನ್ ಟು, f of x is not onto, so it is not a bijective function. So f of x is not a bijective function, bijective function. Clear students? Then we'll go for the third one. So third one, so second problem in solve model same similar other, but condition here it is different. In second problem it was from n to n, here it is from n to y, and y he has defined over here. Given function is again f of x square. So prove that it is a bijective function, he says. When he says prove that, means it is even 1 1 and onto. So this he has asked in July 14. So first I will write n and y. So n natural number is there. So n set if I take 1 2 3 so on. Now if I take y, so to find y you are required to use this condition, you are required to substitute in this condition. X belongs to n, he says. If you put x is equal to 1, you will get y is equal to 1. If you put x is equal to 2, 2 square 4, you will get y is equal to 4. If you put 3, you will get 9, so on. So set y contains 1, 4, 9, 16, 25, 36, so on. So again given function is f of x is equal to x square. F of x is equal to x square. Now same in last problem how I have solved, same will take. So first I will check 1 1. So first 1 1. So let f of x1 is equal to f of x2. F of x1 is equal to f of x2. Substitute over here, simplify. You will get x1 is equal to x2, same as the last problem. So if you substitute, you will have x1 square is equal to x2 square. Take it to the LHS, x1 square minus x2 square equal to 0. Simplify this, that is a plus b into a minus b, x1 plus x2 into x1 minus x2 equal to 0. Again this plus x1 plus x2 will not be equal to 0 because it belongs to natural numbers. So x1 plus x2 not equal to 0 because x belongs to n, natural number. So therefore you will have x1 minus x2 equal to 0, x1 is equal to x2. So if x1 is equal to x2, then we say that function is 1, 1. So f of x is 1, 1. F of x is 1, 1. Clear, students? Now second. So we will check onto. So if I take onto. So onto for all values of b belongs to y. So b will be in this second set y. I should get a as a natural number. A belongs to n. So b will be in this second set y. A will be in this first set n. So if a belongs to n, then it is onto. Now in this problem he has asked prove that, means surely we will get onto. So now if I start, let f of a is equal to b. Again a, if you substitute in given function, if you substitute a, you will have a square is equal to b. So if you take root a is equal to root b. Now here b belongs to y, so values of b will be 1, 4, 9, 16, 25. So b will never be equal to 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, so on. So if b is 1, a is 1. When b is 4, a is 2. When b is 9, a is 3. Means you will get all natural numbers. So you can say this belongs to n. Therefore, f of x is onto. Clear, students? Will clear adare b value 1 ಆಗ್ತದೆ, 1 ಆದ ಕೂಡಲೇ 4 ಆಗ್ತದೆ, 4 ಆದ ಕೂಡಲೇ 9 ಆಗ್ತದೆ. ಇದರ ನಡುವಿನ ವ್ಯಾಲ್ಯೂ ಅದು ತಗೊಳ್ಳೋದಿಲ್ಲ. ಸೊ b ದ ವ್ಯಾಲ್ಯೂ 1, 2 ಆಗೋದಿಲ್ಲ, 3 ಆಗೋದಿಲ್ಲ, 4, 5 ಆಗೋದಿಲ್ಲ, 6 ಆಗೋದಿಲ್ಲ, 7 ಆಗೋದಿಲ್ಲ, so on up to 8. Again it takes 9. So 9 ಇದ್ದಾಗ 3 ಆಗ್ತದೆ. Then again up till 16 it will not be there. So 16 ಇದ್ದಾಗ 4, so it becomes onto. So as function is 1, 1 and onto, given function is bijective. So finally you write, therefore f of x is a bijective function. So this has asked for 5 marks. So if you observe, problems are very simple and it is easy to score 5 marks by solving this. We will go for the next one. So fourth one. So this has asked thrice in March, July, March 20. So again function is from natural number to y. Function is 4x plus 3. Y he has defined over here. So this is similar to last problem. Show that it is 1, 1 and onto. Means you are required to show both it is 1, 1 and onto. Can you solve with me now, students? So first you write a set of n. N is a natural number 1, 2, 3, so on. Then you write y. So y, if you substitute 1, if you substitute 1 over here, 4 plus 3, 7. So first one is 7. If you substitute 2, 4 into 2, 8. 8 plus 3, 11. If you substitute 3, 4 3s are 12, 12 plus 3, 15, 15, so on. So again here, y will take values of 7, 11, 15, so on. Y will not be 1, 2, 3, 4, 5, 6. Again 8 to 10, then 12 to 14, so on. So it will take first value as 7, next 11, then 15, so on. So again first we will check 1, 1. So first given function if I write. Given function is f of x is equal to 4x plus 3. So first we will check 1, 1. So 1, 1. So f of x is equal to 4x plus 3. So let f of x1 is equal to f of x2. f of x1 is equal to f of x2. So if I substitute 4x1 plus 3 is equal to 4x2 plus 3. In this function, in place of x substitute x1 and in place of x you substitute x2. Again take all these terms to LHS, 3 gets cancelled, you will have 4x1 minus 4x2 equal to 0. Take 4 common, so you will have x1 minus x2 equal to 0. So 4 if it goes to the RHS, you will have x1 minus x2 equal to 0. So therefore x1 is equal to x2. So x1 is equal to x2 means given function is 1, 1. Therefore f of x is 1, 1. F of x is 1, 1. So second, if I take onto. So if I take onto. So onto B will belong to y, A has to belong to n. So again for all values of B belongs to y, A should belong to n. So now I will take, let f of A is equal to B. F of A is equal to B. So if I substitute f of A in given function, so f of A will be 4A plus 3 is equal to B. Now simplify this and find A, it has to be natural number. So 4A is equal to B minus 3. Therefore A is equal to B minus 3 divided by 4. Now, if you substitute B values and check, so this is for our purpose, in exam you need not write this. So first B value will be 7, B belongs to y. So if you take 7 over here, so A is equal to 7 minus 3 by 4. So 4 by 4 you will get 1, 1 is a natural number. If you substitute B as 11, B value will not be 8, 9, 10, 11, directly it will be 11. So if you substitute 11, 11 minus 3 by 4, 11 minus 3 is 8, 8 by 4 is 2, so 2 is also a natural number. Similarly, if you substitute 15, 15 minus 3, 12, 12 by 4 is 3, it is also natural number, so you may say it belongs to n. A is equal to B minus 3 by 4 belongs to n. So therefore f of x is onto. F of x is onto. So he has asked to prove that. So if it is 1, 1 and onto, then we say that given function is bijective. Clear, students? So again in next video I will solve few more problems on 1, 1 and